Hello, and welcome to episode 1 of Advent of Code. So, Advent of Code is a challenge that kind of comes once a year around Christmas time. Essentially, they give you a bunch of requirements. They give you an input, so this is my input, and with a set of requirements that they give you here, you have to enter an answer for them. So I think this is good because it kind of gives you a sense of what coding is like in the real world. You know, you're handed a set of requirements and you're told to answer a thing, so this might be quite fun. So we're starting in 2015. This is the first year that Advent of Code kind of did challenges. So let's jump right in with not quite Lisp. So Lisp is a programming language, so this might be interesting. So they kind of like to give a little bit of fluff. Let's start here. Here's an easy puzzle to warm you up. Santa is trying to deliver presents in a large apartment building, but he can't find the right floor. The directions he got are a little confusing. He starts on the ground floor, floor 0, then he follows the instructions one character at a time. An open parenthesis, meaning this, means he should go up one floor, and a closing parenthesis means that he should go down one floor. The apartment building is very tall, and the basement is very deep. He will never find the top or bottom floors. Okay, so this is basically telling us. So this is telling me that, like, you know, if we have multiple close parentheses, it keeps on going down. It doesn't matter. So maybe we need like a very large number here. So I might go for a long. So the way I would go about this. So if we jump into our editor here, and I'm going to make a couple of folders. So directory, this will be 2015, delete this, add directory 2015, and then add a directory for day 1, add a directory here for day 1. Now I already have some code elsewhere to kind of load files from a resource, so I'm just going to steal that because I know for one thing, like having a file loader is very nice, especially with these problems. So let's add a file reader. Sure. This always looks the same. So essentially this just loads a file which is an assembly reference. So let's add day 1 tests. Day 1 tests. Yes. Keep on forgetting to just say ignore it. Okay, so here we'll say when given a open parenthesis, then 1 is added to floor count. And because I am using XUnit, this will be a fact. So we've got an input, and literally it's just an open parenthesis. Nice. Okay, so I guess in here we'll have a floor parser. This feels weird. And here we'll just have we'll have a record. This is a new C# thing called floor, and then in here we'll just have floor number. We could just have it as an int, but this might expand. Who doesn't know? Who knows? You know. So this will return a floor, and then let's just call it parse for now. This will be static floor, and it will take an input. So basically what we want to do really is do an input.count, so the link count, where C equals open parentheses, right? This is kind of cheap, and that can, oh yeah, new floor, and then pass this in as the floor number. Please give me my cursor back, thank you. And then floor parser equals floor parser. This hasn't got a reference, so let's add that reference. Dot parse input. Cool. And this can turn to a const, and then we can say assert equal 1 floor parser dot floor number. This is actually a floor because the floor parser gives us back a floor. And now we can kind of run this test to see if it passes. Awesome. So now we can say given a closed parenthesis, then 1 is subtracted to floor count. So here we want to say this is -1. So in our floor parser, this now becomes a little bit floors to add, floors to subtract, and we want to say input. Well, I guess here's another way of doing it, right? So we can say for each character in input, and then we'll have a floor number which is 0. I can't have char because that is a reserved keyword. Character, and then we can say floor number plus equals input switch, which is kind of a new C# thing. And then if it is an open parenthesis, then it's add 1. If it's a closed parenthesis, then it is -1. And then in the default state, tell you what, and then in the default state we can just say floor number add 0 or something, because it never will be the default case, but you know, you never know. This needs to be character switch. Awesome. And then that turns into that. That's just a neater way of doing it. This is why I love Rider. So essentially what I did there is I thought about it a bit. I said, well, if we loop through our characters, then essentially what we're doing for every character that is an open parenthesis, and every we're adding 1, and then for every closed parenthesis we're just minusing 1, and then, you know, for everything else we'll just add 0. So I thought about it in a loop rather than, because what I had before was looping through it. It's just that it wasn't, I guess it wasn't apparent because it was a function call. So let's run this. This returns true. So now we can kind of add one more test, which is when given an input, expected floor count is returned. And here, this can be a theory, and then we can pass it inline data, and then we'll have the input and then expected floor count. So string input int expected floor count, and then literally all we'll do is change this for this parameter, and then we'll change this assert, and then Nick steal these from the examples that they give us. So this would be floor 0, this would be floor 0, so we can just control D. This would be floor 3. And this would be floor 3. This apparently is floor 3. This is floor -1. This is also -1. And we're just adding tests so that we know our code is completely correct. This can go away. And this is -3, and also this is -3. Oops. Awesome. And then we can run this, and then hopefully this is all correct. Awesome. So I guess now we can get our nice input. We can add a file, call this puzzle input. Do not ask me again. Awesome. That looks legible. Go into properties. This is an embedded resource. Go here, and then we can just call this test solve puzzle 1. Easy. So this is why we had that file reader. This can be static, I guess. Get resource, and the way that this works is that we need the namespace, so we need to just get all of these nice folders, and then the name of the file, and then this is our input, and then we can console.writeLine, which isn't correct, but it will correct us. Another great thing about Rider is that it corrects you when you're wrong. It has added a test output helper to my constructor here, which is awesome. And then hopefully, when I run this, it will actually give me an error, because it couldn't load the file because is this an it is an embedded resource. I have put .text at the end of it, which is another great thing I do all the time. This is because I'm just going to see how I've done the other ones. You never know. I might have done something silly. Nope, I don't think so. So let's just debug this. What I'm expecting here is it will load the actual file. It's got the current assembly, and the stream is null. Advent of code.tests. Let's just see. Oh, okay. It's because I have stupidly named my namespace 2015, and you can't start a namespace with a number. So it's put an underscore there implicitly. Okay, 232. So hopefully, when I go back here and then say 232, hey, we get a gold star. Cool. So now we've progressed on to the next. So they're going to change the requirements on us a little bit. Now given the same instruction, find the position of the first character that causes him to enter the basement, floor -1. The first character in the instructions has position 1. The second character has position 2, and so on. For example, close parenthesis makes him go into the basement at position 1. Okay. So you know how I was saying before that this might expand? This is going to expand. I guess. So let's pause, let's say puzzle 2. So this actually needs to come back into a for each for now, because actually this might actually have to be a for loop now. So if floor count is actually lower than 0, then this is the floor var entered basement at floor position and then I guess I'm not sure what to call this, but we'll call it floor with basement position, I guess, for now. I mean, these things don't have to be like, you know, we're not going to hand them into our boss or anything, so int entered basement at position so hello selecting everything and then I guess here we can say 0 because we didn't, or I guess this can be nullable. I mean, I don't think it will happen, so... Like, I'm just trying to think as, like, a real programmer right now, but... I forget, like, Advent of Code isn't really the time to be... You know, like, doing things massively, you know, perfect. We are at... And then we just want to say index plus 1, essentially. So whenever the floor number gets below 0, we're just going to, like, record that number. So we can test this again. When given an input expected floor count, our expected basement position is returned. This is string input, and then basement position. This should be a theory. I can't find my mouse. There's my mouse. That was weird. So this is just a closed parenthesis, and this is just 1. So let's steal this, put it into here, and say parse puzzle2, which should give me... Let's change this to basement position, or basement at position. It's not like a great name, but you know, as I say, it's not the time to be like over-engineering things right now. Awesome. And then this one, he enters the basement at position 5. Awesome. And then we can solve puzzle 2, hopefully. Basement position. So I'm just writing this into a tuple. Actually, you know what? It was actually fine not as a tuple, because records have this default printing where it just like prints as a JSON object. So like it's actually great. Basement at position 6047. So I don't know whether this is right, but that's not the right answer. Is too high. I would have expected so. So, I guess what are we doing? What are we doing wrong? So this can turn into this, I guess. So let's just read the requirements again. Find the position of the first character that causes him to enter the basement floor -1. The first character in the instruction has position 1. Yeah, so whenever we... So basically, whenever this is -1... So let's just run the tests again. Let me just reposition here while we're doing this. So we're still getting the same answer of 6047. Which, if I remember correctly, this was too high, right? Oh, have we crashed? Have we crashed the website? Oh, we have. Oh no. It's not the right answer, no. Didn't think so. So we got all of the examples correct. Let's just hit this for a second. Let's debug it. Let's see, because it's going to hit here. And the index is actually at 1782. Oh, I see what's happening. Okay, so basically, we haven't added a check to say, because obviously we might enter the basement multiple times. I see what we've done. So if this, what we need to say here is that if this is not null, yeah. Wait, what? Sorry. If this is null, so we can say is null, and the floor position has gone into the basement, essentially, then the entered, yes, okay. Because we might actually go into the basement, set that as the index +1, and then go into, like, we might climb out of the basement and then go back into the basement later. I don't know why Santa would do that, because the pathing is wrong, but, you know. That's a fun little puzzle. Yeah, okay, now we get 1783. There we go. Yeah, that makes... I like that they tried to trick you like that. They knew what I was going to do there. Obviously, this isn't like the best code in the world, but, you know, we solved the problem. We earned ourselves 2 stars. So, yeah. I hope that you enjoyed me solving those puzzles. I shall do some more, maybe when I'm not looking like Emperor Palpatine. And yeah, I hope you enjoy the series of me going through Advent of Code and you kind of seeing my thought process. Obviously, these are going to be a bit longer and a bit more rambly and stuff, but I hope you enjoyed. Thank you.